Now let us start with the new chapter, that is trigonometry. Trigonometry is made up of three words, that is trigonometry. So tri means three, gon means sides, and metry means measurement. That are Greek words which are used here. So trigonometry is the study of relationship relationships between sides and angles of a right triangle, right angled triangle. So here in this chapter we will be talking only about right angled triangles. Whether it is said or not, it will be a right angled triangle. Now let us see it. So now this is ABC, a right angle triangle with sides AB, BC and AC. And angle B is 90 degrees, so opposite of angle B is called hypotenuse. Opposite side of angle B is called hypotenuse. The angle which is given, that is angle A if we are talking, so AB is my base and BC will be my perpendicular or opposite side. And AB will be my base. As BA is touching angle A, so it will be adjacent side or base. Many people talk it as base, many say adjacent side. Both are correct. And here short forms will be used. So for perpendicular P, hypotenuse H, and adjacent side it will be B. Now let us see the same relation for angle C also. So ABC, so angle B is 90, so opposite side will be my hypotenuse, and now BC will be my adjacent side and AB will be my perpendicular or opposite side. Now to remember here the formulas of sin theta, tan theta, cos theta, we have a technique. Pandit Badri Prasad हर बोले सोना चांदी तोले. Here we have to take the first letter only of each one. So as Sona means sine, and that will be P upon H, that is perpendicular upon hypotenuse. Then cos theta will be B upon H, that is Badri's B and hers H. And same way tan theta will be P upon B. Prasad upon Bhole, B. Now three more relations are there, that is cosec theta, which is reverse of sin theta. So hypotenuse upon perpendicular. Now then comes sec theta, which is reverse of cos theta, that is hypotenuse upon base, and cot theta, which is reverse of tan theta, so B upon P. Now let us discuss first exercise. Question 1 says find sin A, cos A, sin C, cos C here. And two sides are given AB and BC. So first, to find the third side or the hypotenuse, we have to use Pythagoras theorem. And Pythagoras theorem is AC square equal to AB square plus BC square. So now AC I don't know. So AB is 24 square plus 7 square. So that will be 576 plus 49. So that will be 625, which is equal to 25 square. So AC is 25. Now all the three sides are known. So sin theta or sin A will be opposite upon hypotenuse. So that is BC upon AC. So that will be 7 upon 25. Opposite side will be BC and adjacent side will be BA and hypotenuse will be 25. So P upon H. So that will be 7 upon 25. Now cos A will be base or adjacent upon hypotenuse. So that is 24 by 25. Now B1, in B case I am given sin C. So sin C's opposite side will be BA upon AC. So P by H again, so 24 upon 25, and cos C will be B by H. So that will be 7 by 25. Now question 2 says find tan P minus cos R. I am given two sides, that is hypotenuse is given and perpendicular is given, base is not given. So again I have to use the Pythagoras theorem to get the base first or the adjacent side first. So again I can say PR square equal to PQ square plus QR square. So 13 square will be 12 square plus QR square. So 169, QR square will be 169 minus 144. So that will be 25. That is QR equal to 5. So now third side I got. Now I have to find tan P. Tan means opposite upon base. So using the technique Badri Prasad Har Har Bole. So tan P will be P upon B. So the cot R will be B upon P. Opposite upon tan P will be P. So opposite to P is 5. So 5 centimeter, that is 5 upon base is 12. And cot R will be cot R. Now base is 5. So base will be 5 upon 12. So they have asked us tan P minus cot R. So that will be 5 upon 12 minus 5 upon 12. So I will get 5 upon 12 minus 5 upon 12. So that will be equal to 0. Now third one, it is given sin A equal to 3 by 4, cos A and tan A I have to find. So sin A. So sin A is nothing but opposite upon hypotenuse. So I am putting the values BC as 3 and hypotenuse as 4. So AC square will be equal to AB square plus BC square. So 4 square equal to AB square plus 3 square. So AB square will be 16 minus 9. So that will be 7. So AB equal to root 7. So I got all the values. Now cos. So cos A equal to base upon hypotenuse. So that will be root 7 and tan A is perpendicular upon base. So cos A will be root 7 by 4 and tan A will be equal to 3 by root 7. Now fourth one says 15 cot A equal to 8, find sin A and sec A. So here see cot means base upon hypotenuse. Oh sorry, base upon perpendicular. So here base is 8 and perpendicular will be 15. So using Pythagoras theorem, AC square equal to AB square plus BC square. So that will be 8 square plus 15 square. So 8 square means 64 plus 225. 289. So that will be equal to 17 square. So AC equal to 17. Now all the three sides we have got. Now cot A will be equal to 8 upon 15. Now I have to find sin A. So sin A equal to opposite, that is perpendicular upon hypotenuse. So that is 15 upon 17 and sec A. Hypotenuse, that will be opposite of cos. So hypotenuse upon base. Hypotenuse upon base. So that will be 17 upon 8. Now fifth one, he has given us sec theta equal to 13 by 12. Find all other relations. So now here sec means hypotenuse upon base. So hypotenuse and base I have kept. So using Pythagoras theorem, that is AC square equal to AB square plus BC square. So 13 square equal to 12 square plus BC square. So BC square will be 169 minus 144, that is equal to 25. That is equal to 5 square. So BC I have got 5. Now sin theta will be equal to perpendicular upon hypotenuse. So that will be pi upon 13. So cos theta will be base upon hypotenuse. So that will be 12 upon 13. Tan theta perpendicular upon base. So that will be pi upon 12. Now cosec theta will be opposite of sine. So h by p. So 13 by 5. And cot theta will be opposite of tan theta. So base upon perpendicular. So 12 upon 5. So all the relations are achieved. Now, sixth one, he says angle A and B are acute angles, cos A equal to cos B. Then prove that angle A equal to angle B. Let us assume triangle ABC be a triangle such that CD is perpendicular to AB cos A equal to cos B. That is given. So cos A AD upon AC equal to cos B. So cos B will be BD upon BC. So AD and BD are equal upon BD equal to AC upon BC. Let this be K, that is constant. Now AD equal to KBD, so 1, and AC equal to KBC, so 2. Now using Pythagoras theorem in triangle CAD and triangle CBD, CD square equal to BC square minus BD square, that is third, and CD square equal to AC square minus AD square, that is fourth. LHS of 3 and 4 are equal, so BC square minus AD square equal to AC square minus AD square. So in 1 and 2 I have got the values, so let me put BC square minus BD square equal to AC KBC square minus AD is KBD whole square. So that will be K square BC square minus BD square. Now both sides I have got BC square minus BD square. So if I can cut that, so let me cut that. So I can say K square equal to 1. So therefore AC equal to BC. So if AC equal to BC, then angle A equal to angle B. Opposite angles of equal side are equal. Now seventh one is cot theta is given as 7 upon A, 7 upon 8, and I am asked first 1 plus sin theta into 1 minus sin theta whole upon 1 plus cos theta into 1 minus cos theta. And second one, it is asked cot square theta. Now already I have done the Pythagoras theorem and I have shown that the third side I am getting as root 113. So the first one will be equal to, so A minus B whole square formula I have used, so 1 minus sine square upon 1 minus cos square theta. Now I need sine theta's value and cos theta's value. So sine theta will be 8 upon root 113 and sine square theta will be 64 by 113 and cos theta equal to 7 by root 113. So cos square theta will be 49 upon 113. So now putting the values, 1 minus sine square theta upon 1 minus cos square theta will be equal to 1 minus 64 by 113 whole upon 1 minus 49 upon 113. Now doing the LCM in numerator and denominator, so 113 minus 64 upon 113 whole upon 113 minus 49 upon 113. So denominator gets cancelled of both, so I get 49 upon 64. Now cot square theta 10. So base upon perpendicular. So base is 7 upon 8. So 7 square upon 8 square. So 49 upon 64. Now eighth one is 3 cot A equal to 4. So cot A equal to 4 by 3 and find 1 minus tan square A upon 1 plus tan square A equal to cos square A minus sin square A or not. So here also first I have used the Pythagoras theorem and find the third side using the given values. Now tan A will be opposite upon base. So 3 by 4. So 10 square A will be 9 by 16. Sin A will be 3 by 5 perpendicular upon hypotenuse. So 3 by 5. So sin square A will be 9 by 25 and cos A will be based upon hypotenuse. So 4 by 5. So cos square A equal to 16 upon 25. Now let us put the values LHS. So 1 minus tan square A upon 1 plus tan square A equal to 1 minus 9 upon 16 whole upon 1 plus 9 upon 16. So doing LCM in numerator and denominator, 16 minus 9 upon 16, 16 plus 9 upon 16. So 16, 16 cancel, 6, 7 upon 25 I got. Now let us solve RHS. So that will be cos square A minus sin square A. So cos square A is 16 upon 25 minus 9 upon 25. So LCM will be 25. So 7 upon 25. So therefore LHS equal to RHS. So I can say 1 minus tan square A upon 1 plus tan square A equal to cos square A minus sin square A. Now ninth sum is tan A equal to 1 upon root 3. Find sin A cos C plus cos A sin C. Second one is cos A cos C minus sin A sin C. So again I have done the hypotenuse. First I have found that is AC is 2. Now sin A will be opposite upon hypotenuse. So 1 by 2 cos cos A will be root 3 by 2 sin C. So sin C equal to root 3 by 2 and cos C equal to 1 by 2. So now finding the values of first one, that is sin A cos C plus cos A sin C. So that will be equal to 1 by 2 into 1 by 2 plus root 3 by 2 into root 3 by 2. So that will be equal to 1 by 4 plus 3 by 4. So that is 4 by 4. So that is equal to 1. Now second one, cos A cos C minus sin A sin C. So putting the values again, so cos A is root 3 by 2, cos C is 1 by 2 minus 1 by 2 into root 3 by 2. So that will be root 3 by 4 minus root 3 by 4. So that will be equal to 0. Now 10 sum is PR plus QR is given 25 and PQ equal to 5. So let us take QR equal to X first. one side is given as pi and sum of other two sides is 25. So let QR equal to x centimeter. So therefore PR will be 25 minus QR, that is 25 minus x. So now using Pythagoras theorem, PR square equal to PQ square plus QR square. So PR is 25 minus x whole square equal to PQ is 5. So 5 square plus x square. So 25 square will be 625 minus 50x plus x square equal to 25 plus x square. So x square got cancelled. 625 minus 25 equal to 50x. So x equal to 600 upon 50. So 0 cancel, 5 12s. So x equal to 12 centimeter. So if x is 12 centimeter, so QR will be 12 centimeters. So PR equal to 25 minus 12. So that will be 13 centimeter. Now he is asking us to find sin P. So sin P will be opposite. So QR upon PR. So that will be 12 upon 30. Then cos P equal to PQ upon PR. PQ upon PR. So PQ is 5 upon 13. And tan P equal to QR upon PQ. So 12 upon 5. Now 11th sum is the value of tan A is always less than 1. Just say true or false and justify your answer. False, because in triangle M and C, angle N equal to 90 degree, MN equal to 3 centimeter, NC equal to 4 centimeter, and MC equal to 5 centimeter. 10 10m will be 4 by 3, which is more than, greater than 1 or more than 1. Whatever you write, both are correct. Second one is sec A equal to 12 by 5 for some value of angle A. True. Let triangle M and C be there with angle N equal to 90 degree, MC equal to 12, MB equal to 5. So MC square will be equal to MN square plus NC square. So 12 square equal to 5 square plus NC square. So 144, MC square will be 144 minus 25. So that is 119 K square. So such triangle is possible, therefore it is true. Third one, cos A is the abbreviation used for the cosecant of angle A. So that is true, as we write short form of cosecant as cos A. So now fourth one is cot A. is the product of cot and A. False, as A is not the product of cot and A, but cot A means angle, cot of angle A. So sin theta equal to 4 by 3 for some angle theta. This is also false, as sin theta can't be more than 1. So sin theta equal to opposite upon hypotenuse. Hypotenuse is the longest side of the. So if the longest side is 3, the smallest side can't be 4. Therefore sin theta cannot be greater than 1.